Hey guys, good morning. We're going to be adding, subtracting mixed numbers now. So if you remember from yesterday's notes, we added, subtracted fractions, proper fractions, okay? And pretty much the steps are the same. So you're always going to have to look at those denominators and then rename the fractions if, once you find the common denominator, okay? So go ahead and press pause and copy down the notes. Make sure you do leave yourself space, especially going off to the side, please, okay? And we'll get some of this work done for you, all right? Okay, so let's take a look. Steps are the same, okay? So step one, if the denominators are not the same, we have to do the LCD, okay? So take a look at the denominators. If they're the same, you're ready to work. If they're not the same, then you're gonna have to do the LCD by doing the T-chart, okay? Or if you know it in mental math, go ahead and do that, okay? But now that we have mixed numbers, something might happen. We might have to borrow, okay? We might have to borrow. And we can borrow if we have a whole number, and that's why I do the mixed numbers on a separate day, okay? So this is how you're gonna have to borrow. You're gonna borrow 1 from the whole number. So we're gonna take 1 away from the whole number, just like we would do if we were borrowing in decimals or other natural numbers, okay? Then we're going to add the numerator and the denominator together. My art didn't come out, sorry. And that's going to replace the old numerator. Okay? And of course, the denominator stays the same. So in these first 3 examples, I'm going to show you how to borrow, and then we'll actually get into the adding, subtracting of mixed numbers, okay? So how to borrow. Okay? Take 1 away from the whole number. So this 4 goes down into a 3. So now I have 3 wholes, okay? So now I have 1 whole pizza. This pizza is cut up into 3 pieces. That the bottom number always tells you how many it's cut up in. So it's cut up in 3 pieces, okay? So I have this 1 whole pizza that has 3 full slices. I'm gonna add those 3 full slices to the 2 slices I already have, okay? So what you're doing is you're adding 3 plus 2. Okay, I'm adding the 3 whole slices that I have because I took 1 away, and I'm adding 2 more. And so 3 plus 2 is 5. Okay, so when you rename this, when you borrow from it, the 4 turned into a 3. I added 3 plus 2 to get 5, and my denominator stays the same. That's how you borrow. Okay, let's try it again. Make sure you get it. Let's pretend I have to borrow here. Step 1, I'm going to take 1 whole pizza away from the 9, and that turns into an 8. Okay? Now you're going to add 4 plus 1, because I add denominator plus numerator. 4 plus 1 is what? Is 5. So when you rename this, the 9 turned into an 8. My numerator is now 5, and the denominator stays a 4. Okay? So a lot of students, what they want to do, they want to turn this 1 into 11. That's not the case. We're not adding 10 pieces of pizza. We're just adding 4 in this problem. We're not going to turn this to a 12. I'm not adding 10 slices of pizza. I'm just adding 3 because that's what I cut it up into. Okay, and that's why you're having to add the denominator plus the numerator. Okay, so the last one here, to borrow. The 2 changes into a 1. Okay, and then I'm going to add 5 plus 3 is 8. So that gives you 1 and 8 over 5. Okay, and that's how you're going to borrow if the top numerator is smaller than the second mixed numbers numerator. Okay, you're going to see that happen in subtraction only. Okay, so let's get started. Let's go ahead and add some mixed numbers. The first thing you have to do, just like with yesterday's lesson, is check those denominators. And in this scenario, They are the same, so I don't have to do that extra step of LCD, okay? I just go ahead and add. So we're going to go ahead and add our numerators together. So 1 plus 1 is 2. My denominator, if you remember, stays the same, so that is 2. And then don't forget to add the whole number. Sometimes we forget to add them, okay? So 2 plus 3 is 5. Are you done? No. 2 over 2, okay? So if I take 2 and divide that by 2, what do I get? 1. So I need to add this 1 whole to the 5 wholes, and I get 6 wholes. So 6 is my actual answer. Because remember, any number over itself, if the numerator and denominator are the same, you're always going to get 1 as an answer. Always 1. Okay? Good. Let's go to number 2. First thing you look at, denominators. They're not the same. No. Which means we have to do some extra work. Let's go do the LCD. So you should know 3 and 6 by now. But if not, do your trusty T-chart. So 3 times 1, 3 times 2, and 6 is our lucky number. Now, when you rename, the whole number stays the same. That is not going to change. That stays the same, okay? So I know my denominators, because we're just changing the fraction. I'm not changing the whole number. I'm just changing the fraction, so be careful, okay? Now let's rename the numerators, because that is the fraction. So we did 6 times 1 to get 6. So do the exact same thing. 1 times 1, that gets you 1, okay? Now we did 3 times 2, that gave you 6. So then 1 times 2 gives you 2, okay? Now we are ready to put it all together, okay? Go back and check. This is an addition problem, so I want to make sure I am adding. So I am doing 2 plus 1 is 3, and my denominator stays the same, so it's a 6. And don't forget the whole numbers. 3 plus 1 is 4. But then just like always, ask yourself, can I simplify my fraction? And in this example, we can, okay? If you look at 3 and 6, what number can I divide both 3 and 6 by? I can divide them both by 3, okay? So 4 is your whole number. 3 divided by 3 is 1. 6 divided by 3 is 2. Remember, nothing happened to the whole number, just bring them over. So 4 and 3, 6 reduces down to 4 and 1/2, and that is your final answer. Okay, good. Now let's go to the subtraction. Okay, let's take a look. 4 and 3/12 minus 8/12. Okay, first thing we look at, denominators, and they're the same, so no extra work here. Yay. So let's go ahead and take a look. 3 minus 8. Can I take 8 from 3? This is the instance you're going to have to borrow, okay? When my numerator up here is smaller than my numerator down here, you have to borrow. So you remember how we borrowed up here? We do the same thing to this top number. The 4 turns into a 3, okay? And then I add my numerator plus my denominator. So I add 12 plus 3, and that gives me 15, okay? So the 4 changed to a 3. The 3 is now 15, okay? And now we're going to go ahead, and you can always rewrite it if you need to. I'm just out of space, so I can. Okay, so I'm going to go ahead and subtract 15 minus 8. That's 6, if I did my math right. 7, mornings. And my denominator stays the same. So I did 15 minus 8 is 7, and 12 comes down. right? Yeah. Now, don't forget the whole numbers. What is 3 minus 3? 0. I don't have to put the 0 there. Can you simplify 7 over 12? So your final answer is 7/12. Okay. All right, let's go to the next one. Luckily for you, I went ahead and kept the denominators the same. Okay, that way you don't have to do the extra work. But if they were different, you have to find the LCD and change them before you can even think about borrowing. Okay, you only borrow after your denominators are the same. So take a look. Can you take 6 from 1? Okay, no, my numerator up here is smaller than the numerator down here. So we have to borrow. So following the steps from above, okay, my whole number reduces by 1. That turns into a 5. Then I'm going to add 9 plus 1, which gives me 10. Okay, got that again. My whole number reduces by 1. Let me write that better for y'all. Okay, I don't like how it is right here. So hopefully on yours it looks pretty. There. So my whole number reduced by 1 to a 5. So the 6 has gone down to 5. Then I've added the denominator plus the numerator. So 9 plus 1 gave me 10. Okay. Now I can subtract. 10 minus 6 is 4. And then my denominator stays the same. It's going to be a 9. Okay? Don't forget the whole numbers. So 5 minus 2 is going to be 3. Can you simplify 4/9? So your answer is 3 4/9. Okay? So again, as soon as I saw that I could not subtract 1 minus 6, I took a 1 away from the 6, turned it into a 5. Then I added 9 plus 1, which gave me 10. Then I subtracted 10 minus 6 is 4. My denominators are 9, so my 9 comes into my answer. And then I did not forget my whole number, so 5 minus 2 is 3. Okay, now let's do this one. It looks hard. Most kids right here will put 2 1/8 as their answer. 2 1/8 is not your answer, okay? You have to borrow. So just like if you had decimals and you had a point, like 34 minus 2.8. You had to put the 0.0 on top to borrow. Same concept here, okay? So I have to borrow and turn it into a fraction. So the 8 goes into a 7. That's easy. But over here, I don't have a numerator or denominator to add to, okay? But what's special about this is I'm borrowing one whole pizza, okay? I need the same denominator. So I'm going to cut this pizza into 8 slices because I need my denominators to be the same. If I make them different, I'm adding more work, okay? So I have 8 there, 8 slices. Now, since I took away one whole pizza, that means I did not eat any slices, so I still have 8 slices. Because you remember from before, any number above itself equals 1, and we just took 1 away from the whole, okay? So figure out what your denominator is over here, and just put it over itself, and you're done, okay? Now we can subtract. 8 minus 1 is 7. Denominator is the exact same, 8. And now we subtract our whole numbers. 7 minus 6 is 1. So 1 7/8. Okay? Again, if you have questions, come to me and we can do some together on Google Meets, okay? Now you can take a look at these real quick just to make sure. You don't have to write these down, okay? But let's say I have 4 1/10, and I want to subtract 2 8/10, okay? This is what's happening again. I need to borrow because I cannot take 1 and 8. So the 4 turns into a 3, okay? And then I'm going to add 10 plus 1. That gets you 11. Now you can go ahead and do 11 minus 8. is 3. Denominator stays the same. 3 minus 2 is 1. You can't simplify 3/10, okay? And I'll do another one. Where's my eraser? With the lovely whole numbers. So if I had 16 minus 2 and 3/4. Okay? What's happening here? I can't just bring a 3/4 down. It's like a decimal. If I added a point and 0, I'd have to borrow. Same thing here. So this 16 turns into 15. Okay? Now, since the denominator is a 4, I'm going to make sure this is a 4. And if you remember, any number over itself equals 1. So if I put 1 over 1, that's 1. 2 over 2, that's 1. Since my denominator is a 4, I'm going to put 4 over 4, and that equals the 1 pizza that I took away. Okay? Now I can subtract. 4 minus 3 is 1. Denominator stays the same. 15 minus 2 is 13 and 1/4. Okay? So if we need more examples, come to the Google Meets and we'll do some more there. All right? I want you to go ahead and try these out on your own by yourself, and then press play when you are ready to see the answers. All right, you ready to see them? Okay. Now, right off the bat, sorry guys, I gave you unlike denominators. So if you did your T-chart, remember, whole numbers stay the same. You would have found that your magic number is 14. Okay? And you did 14 times 1, so 9 times 1. 7 times 2, 4 times 2. Perfect. Okay? And I already know 14 is my denominator because that is our magic number, the number they have in common. Then now let's take a look. 8 plus, we're adding here, so I don't have to borrow anything, we're just adding. So 8 plus 9 is 17. And then 2 plus 1 is 3. We're not done yet. Good. So you should have seen that this is an improper fraction. So you should have divided 17 by 14. That goes 1 time. Remainder 3. So I'm going to add this 1 whole to the 3. So 3 plus 1 is 4 wholes now. The remainder is my numerator, and my denominator is the same. So 4 and 3/14 would have been your answer. You got that right? Awesome job. Give yourself a pat on the back on that one. All right, let's take a look at the next ones. They're subtracting. So here, if there's nothing here, the 10 turns into a 9. And then the denominator is a 3, so I'm going to do 3 over 3. Okay, because that equals the 1 whole I subtracted. I took away. I borrowed. So now we're going to do 3 minus 1, which is 2. And then denominator stays the same. And subtract 9 minus 6, 3. So if you got 3 2/3, give yourself a big pat on the back on that one, okay? If you got 4 1/3, you forgot to borrow. That's all, okay? So make sure you do practice the borrowing process. Just make up some numbers and borrow, pretend, okay? Let's check this one out. Denominators, oh, they're not the same. Did y'all find the LCD quickly? Should have been 18. So the whole number stays the same. Denominator is an 18. Whole number stays the same. Denominator is an 18. And my answer, denominator is an 18. Okay? So that is the first part. Now we have to rename the numerators. So we did 9 times 2 to get 18. So 2 times 2 is 4. 18 times 1, so 7 times 1. Can I take 4 minus 7? No, another borrowing. Let me change my color again. So we're going to take 1 away from the 5. That turns it into a 4. We're going to add 18 plus 4, 22. There you go. And now I can subtract. 22 minus 7. 15. And then 4 minus 1. Did y'all notice that you can simplify this one down? Hopefully, yes. Check your work. We can simplify. We can simplify these by 3. Now remember, your whole number stays the same. 15 divided by 3 and 18 divided by 3. I can't go any further. So 3 and 5, 6 is my answer. Okay? How'd y'all do? If you need more help, please private comment me. Okay? If you didn't make the Google Meets, private comment me, Ms. Munoz. I really need some extra help on this. Maybe we can have a one-on-one Google Meet session. Okay? And I can just be me and you doing some more problems together until you get it right. Okay? All right. That's it for today. Tomorrow you'll have a test on adding, subtracting, and comparing, okay, fractions, and also converting between fractions, decimals, and decimals, fractions, all right? So we'll see y'all. No Google Meets tomorrow because it is a test day tomorrow, but always private comment me if you have a question. All right, guys, we'll see y'all. Have a great weekend. Bye.